All right, so we'll be taking up graphing rational functions. So the objectives of this lesson are determine the intercepts of a rational functions, determine uh, and define the vertical and horizontal asymptotes, and then determine whether the graph would have a hole, and then finally sketch. So an introduction again, as I said last time, for rational functions, it would be in the form of p of x over q of x, where p of x, let's take that as the numerator, and q of x, let's take that as the denominator. The restrictions, what are the restrictions? The denominator should never be equal to 0. So whenever the denominator becomes 0, that is your restriction. Whenever the denominator becomes 0, that is what you call an asymptote. Again, what type of asymptote is it? It is the vertical asymptote. Okay? Sometimes, even if it has a denominator, but after you rearrange the function, and then it cancels out, or the term, the denominator cancels out, it would have what you call a hole. I'll show that to you later on. So what is a vertical asymptote? You said before, an asymptote is a line that you approach but never touch. That's correct. So let's be more specific. The vertical asymptote, let line x equals a, is a vertical asymptote for the graph of a function if either f of x increases or decreases without bound as x approaches the a, which is the asymptote, from either left or right. So just like an example here, this is x equals a, the blue line. So as it approaches the right side of a, that's why in here, a plus, meaning a from the right. As it approaches a from the right, it increases without bound. As it approaches a from the left, it increases without bound. So that means that line is your asymptote. In here, as it approaches a from the right side, it decreases without bound. As it approaches a from the left side of a, it also decreases without bound. So that is a vertical asymptote. So let us consider the function. So in here, you'll say, okay, sir, let's factor this out. Yes, we factor it out. So you can say there are two restrictions. One is x is 2, the other one is -2. But the thing is, isn't it that in factoring, you were taught that if it's all multiplication or division and they're the same, you can cancel? Yes, but what I will do is this. You have to take note that this one will give you -2. This one will give you +2. So sometimes I can rewrite that as f of x is equal to 1 over x plus 2. When I cancel out x minus 2, however, I should state that x cannot be 2. Kasi for me to cancel this, the x minus 2 term, x cannot be equal to 2. Why? If x is equal to 2, you will have 0 in the denominator. And if x, again, is equal to 2, you will also have 0 in the numerator. You have to remember that 1 over 0 is undefined. 0 over 0 is indeterminate. Okay? Kaya, if that becomes 0 over 0, it's indeterminate, hindi rin pwede. So I need to define here that this function is equivalent to the one on top. However, that will only happen when x is not equal to 2. So after we establish the restriction, cancel common factors. However, you have to say that x is not equal to 2. But for anything that canceled out, that becomes what you call a whole. So here, let's go back. Because x equals 2 is actually a whole. Ayan no. So let's try these. So in here, I can say this is x plus 3 and x minus 3. First question, can I cancel out anything? Yes. That becomes 1 over x plus 3. But that happens when x is not equal to 3 because this one will give you 3. That will give you negative 3. So what is x equals 3? This is a whole. And then this one, the one left, will be what you call a vertical asymptote. Let's try another one. On top, it becomes x plus 2 and x minus 2. At the bottom, it's x plus 5 and x minus 1. So the thing is, can I cancel out anything? Di ba nothing canceled out? So it can give you two values for x. X is negative 5 and x is 1. Since both values didn't cancel, I can see that there are two vertical asymptotes in here. And there are no holes. Kasi nothing canceled out. Hole is a restriction as well. So just like this one, look at this. Both numerator and denominator should be factored kasi yan, finding the zeros. When we say zeros, they are the roots. So what are the potential zeros? The zeros are also the x-intercepts of the function. So how do you solve for the x-intercept, di ba? X-intercept, when does this happen? Happens when y equals 0. So what we do here is we try to factor out. After we factor out, let's check the denominators. Will there be anything that cancels out? Yes, it cancels out. So I can say that this one may be written as x plus 2, x minus 3, but this happens when x is not equal to negative 1. So x is not equal to negative 1 is what you call the whole kasi that canceled out. So in here, what is left? X plus 2 over x minus 3. X minus 3 is your x minus 3. So when we solve this, this becomes is your vertical asymptote. This one is your whole. So restriction silang dalawa. Yan o. Restrictions, the two restrictions. X minus 1, x minus 1 are the numerators. However, since x minus 1 cancelled out already, it is a whole, isa na lang matitira. The one that's left is the only zero. Paano ba natin makukuha yung zero? Ganito. Y equals x plus 2. X not equal to negative 1. So, ang sabi, 0 daw. So, that means it's the x-intercept when y is 0. So, 0 is x plus 2 over x minus 3. So, in order to solve that, di ba, crisscross, x plus 2 is 0. X is not is equal to negative 2. So, ang x-intercept natin ay negative 2, 0. So, here, horizontal asymptotes. As I said last time, there might be horizontal asymptotes. And look, horizontal asymptotes, you look at them as x approaches positive or negative infinity. Diba? Ito. In this case, positive lang yung ginawa niya. Pero asymptotes, they have similar concepts. They are lines that you want to approach but never touch or cross. However, for horizontal asymptotes, you will notice here that it crossed. But then it will only cross in the middle, not at the extremes. Kasi sometimes ang asymptotes natin, syempre, di ba, you will look at it as it goes extremely to the right or extremely big to the left. So the graph of a function may cross a horizontal asymptote, but it never crosses a vertical asymptote. So to find the horizontal asymptote, this was what I taught you. 2x plus 5 all over x squared minus 3x plus 4 let's check which has a higher degree. Denominator. So how many x squared are there on top? 0x squared over 1x squared, 0. So ang horizontal asymptote mo ay 0. It says there. Next, they are equal in degree. What's the coefficient? 2. What's the coefficient? 1. 2 over 1 is 2. So ang horizontal asymptote mo ay 2. So the leading coefficient of the numerator over the leading coefficient of the denominator. So wala tayong problem if the degree is less or if the degree is equal. The problem, guys, is if the degree is greater. So this is what you call the slant or oblique asymptote, the third type of asymptote that we have. So mas mataas ng degree yung top kaysa sa bottom. What we do here is, let's do long division. You will notice, guys, that there will be an x plus 5 on top. However, there's still some remainder. Pero we don't mind the remainder. What we look at is this. X plus 5. The x plus 5, di ba, y equals x plus 5 is what you call your slant asymptote. Sometimes kasi you might be asked, what is the slant asymptote of this? Di ba? For example, determine the horizontal asymptote, if any, of the function. So, first, horizontal lang naman tinatanong. Pero if I ask you, are there vertical asymptotes? Kasi di ba x minus 3, x plus 2 yung denominator. Therefore, for here, x equals 3, negative 2. They are what you call vertical asymptotes kasi they don't cancel. Pero are there any horizontal asymptotes? Let's look. The degree of the numerator is smaller. What's the horizontal asymptote, guys? So HA, y is 0. In this case, they are equal. So HA, 4. Ito, no HA. So what we do here is, meron siyang slant asymptote. So what we do here is divide. Divided by x squared plus 1. So 2x, it gives us 2x cubed plus 2x. Negative 3x squared minus 2x. So we can still divide. Plus 5. So this becomes negative 2x plus 8, right? We don't care about the denominator. So I can say here that the slant asymptote is y equals 2x minus 3. There's no horizontal for here. Can you follow? All right, let's move to the next. So let's try graphing. In graphing rational functions, actually in any function, we try to follow some steps like here. Factor out numerator denominator to solve for domain and range, vertical horizontal slant asymptotes, and then identify the holes, if any, intercepts, and then the behavior, and then sketch. So, I'll try to give you those steps. Pero ako kasi, personally, guys, I follow certain steps. So, what do I follow? This bar. So, domain, intercepts, symmetry, behavior, asymptotes, and regions. Pero in you, instead of that one, maybe we can follow holes na lang. D bar, DIH bar. So, x plus 1 over 2x. Sige, let's factor this out. So that is 2x and x. Oh, okay. Minus 1. Okay, guys, any questions on how I got this? Okay, so let's go for the domain. Balik na rin natin to, DHI bar, D bar. Domain. Let's look at the restrictions. The denominator cannot be equal to 1/2 or -3. Are there any questions why this is the case? Kasi the domain, look at the denominator. The denominator becomes 0 when x is 1/2, also when x is -3. Eh di ba we cannot have zeros in the denominator? Okay? Now, d bar, so holes. Are there any are there anything that canceled out? There's none. So there's no holes. What's I? I stands for intercepts. And as I said before, there are two types of intercept. What you call the x-intercept. This happens when y is 0, and the y-intercept. When does the y-intercept happen? When x equals 0. So when y equals 0 daw, 0 is x plus 1 all over 2x minus 1, x plus 3. So when I cross multiply, mawawala yung denominator kasi 0 times that. Tama? Therefore, x is -1. Your x-intercept, if I would want to rewrite that in coordinate or in ordered pair, it's -1, 0. Or x equals -1 is your x-intercept. Okay? Now, for y-intercept happens when x equals 0. So, y 0 plus 1, 0 minus 1, 0 plus 3. So 0 plus 1 is 1. -1 times 3 is -3. Therefore, I can see that my y-intercept is 0, -1/3. Okay. D bar. So, sa inyo, siguro, wag na tayong maglagay ng behavior muna. Let's go to asymptote muna. Kasi as I said, this was what I was using in calculus. But sa inyo, konti lang naman the parts. So, vertical asymptotes. Let's look at the denominator. Denominator that did not cancel out. X equals, ano hindi nag-cancel? 1/2 and -3. They are your vertical asymptotes. What about your horizontal asymptotes? Are there any horizontal asymptotes? Let's look. Let's look at the top. The degree of the denominator is lower. Therefore, I have a question. Is there a horizontal asymptote? Y is 0. So, do you have a slant asymptote? There's none. You have a vertical, you have horizontal, you don't have a slant. Now, sometimes we need to check for crossing at HA. So how do you check for crossing? What we do here is the HA, x plus 1 over 2x squared plus 5x minus 3. Yan yung equation natin. What you plug in there is the HA. It so happened that your HA is 0. So I can see that 0 is x plus 1 over pero di ba yung HA ko is actually the same as my intercept in here? Yes, later on I'll show you what happens. We will go now to last natin na part, regions. The regions come from the x-intercept, and the vertical asymptotes. Ngayon guys, what are my x-intercepts? Meron ba akong dalawang x-intercept? Isa lang. Do I have vertical asymptotes? Yes. Ano yung vertical asymptotes ko? Ayun no. I'll encircle what I need ha. Star na lang. What are my vertical asymptotes? 1/2 and -3. So what I will do guys is this. The one that I taught you. Negative infinity. This is -3 first, followed by 1, followed by 1/2, followed by positive infinity. Again, what do I write here? I will write the factored form of the equation or of my function. At the bottom, it's 2x minus 1 and x plus 3. Ayun. Now, guys, can you please tell me where will they zero out? The -3 zeros out here, and then the 1/2 is here. So let's try a test value. Guys, can you please think of a test value? -4. Okay lang. -4, -10, -5, whatever you want. -4, let's try. -4 plus 1 is negative. -4 times 2 is -8 minus 1. It's still negative. -4 plus 3 is negative. So I'll fill out the whole table. So 3 negatives is negative. This one's positive. Okay. So how do we sketch? So far you have a 3. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Sabi regions. -3. What I will do, guys, is I'll create a very, very, very light line to separate them into regions. And then -1 is another region up to 1/2. 1/2 is here. Okay. So this is -1, -3. This is 1, 3, 5. Okay. Now look at the regions, guys. It says there, from -3 papuntang infinity, anong sign niya, guys? Negative. So that means, if it's negative, guys, I should not have any value, any graph on top. I should not be drawing here. Between -3 and -1, anong sign niya? Positive. So if it's positive, bawal magkaroon ng graph between -3 and -1. Now, here from 1 up to 2, up to 1/2 pala, what's the sign? Negative. So that means bawal daw magkaroon ng graph on top. So all those bawal, I shade them para I don't need to graph in them. Now, from 1/2 onwards, positive siya, I cannot have graphs here. You understand, guys? Why I shaded them? Okay. Now let's go to all the parts. It says there, the intercepts are -1, 0, and 0, -1/3. -1, 0 is an intercept, and 0, -1/3. So if this is 1, 1/3 is somewhere here. Okay, they are the intercepts now. Now, do we have vertical asymptotes? Yes, 1/2 and -3. So the asymptotes, I'll make them red. So it's dashed line. X is -3 is a vertical asymptote. Ngayon, ano pa yung isang vertical asymptote natin, guys? Can you please dictate to me what's the other vertical asymptote? 1/2. Therefore, yung 1/2, hindi pala itong 1, itong 1/2 pala. I'll create dotted lines in there. X equals 1/2. So okay na ako. Now, do we have any horizontal asymptotes, guys? Meron. So ang asymptotes ko ito, vertical asymptote, horizontal asymptote, para alam nyo, red. 0 daw. Lahat ng asymptote ko, I'll make them dotted line na red. Okay. Now, I'm done. Wala akong slant asymptote. Now, guys, look. If I were to draw, di ba ang sabi ko, an asymptote is a line that we come near but we never cross or touch sana. So ito, palapit ng palapit sa vertical asymptote. This one, the red one, is a horizontal asymptote. So that means here, ganyan yung shape niya. On the right side, it's also the same. It tries to go near, but it will never touch. Pero in the middle, guys, look at this. You have two intercepts. So from this, let's go to the left side first. From here, I would like to go nearer and nearer my asymptote. Right? Pero, kasi positive lang yung value ko. Pero on the right, ito, pag ganun, lalapit siya sa isa pang intercept. But, as it crosses the intercept, palapit na naman siya sa isa pang asymptote natin. So, that means this is the shape of the curve. Alam ko medyo nakakahilo siya. Pero dito natin magagamit yung table of signs natin. Alam natin, negative sa baba lang yung curve. From 3 to 1, positive, nasa taas yung curve. From negative 1 up to 1/2, nasa ilalim daw kasi negative. From 1/2 up to infinity, positive lang yung curve ko. Wala akong graph sa mga shaded regions. In here, sketch the graph. It's the same. It's exactly the same. Pinakita lang niya restrictions are 1/2 and -3. Identify the asymptotes. Those are already identified. Holes, if any, there are no holes kasi walang na-cancel. So the x-intercept, it was identified. The y-intercept is also identified. And then in here, what I didn't like was there are a lot of additional points. This is really useful, especially if you want to graph it as close as possible to its real value. Pero ako kasi rough estimate lang naman eh. So, di ba, what I have graphed is that, oh, you know, the blue one. Look at the graph, the actual graph. Diba, it's roughly the same as what we drew. So, eto, meron pa siya isang value. Ito naman ang pangit ng curve niya. Pero let's try graphing. Look, are there, do you think magkakaroon ako ng slant asymptote in here? Yes. Why? Because the degree of the numerator is greater. Yes, you will actually have a slant asymptote. Ayan, no? So, how? Kasi what you do here is, you do long division. You'll end up with something like this. So let's start with domain. All right, guys, for domain, again, let's look at the denominators. Are there any restrictions in the denominator? X cannot be equal to 4. Very good. Because the denominator becomes what? It becomes 0. Very good. So domain, let's look for potential holes in the graph. Are there any holes in the graph? None. Bakit? Kasi you can't cancel. Very good. Next, intercepts. How many types of intercepts are there? There are 2. Very good. X-intercept. This happens when y is 0. And then the y-intercept happens when x is 0. So let's plug in 0 in y. let's plug in 0 in x. So here, 0 is x plus 2, x is negative 2. Therefore, I can make that a point that's negative 2, 0. Very good. Here, y is negative 2 over 4 or negative 1 half. So that is 0 minus 1 half. So you have two intercepts. Let's encircle the intercepts so that you know you will be using them later. Now, let's have asymptotes. So you have three types of asymptotes: vertical, horizontal, and slant asymptotes. Is there potential vertical asymptote? Can you tell me, guys? X equals 4. Now, is there potential horizontal asymptotes, guys? The degree is the same, and then the coefficients are 1 over 1. Ba? So it's equal to 1. Very good. Next, are there any slant asymptotes? There's none. Okay, so in here, you have to remember that there is potential crossing of the horizontal asymptote. So what we do here is check for crossing at the horizontal asymptote, which is y equals 1. So what I will do here is I plug in 1 in the equation. So here, let's crisscross. X minus 4 is x plus 2. May problem. Is negative 4 equal to 2, guys? No. So this equation cannot happen. That means, ano ibig sabihin nito? No crossing at the horizontal asymptote. So tapos na tayo dito. After ng asymptotes natin, ano na yung susunod? Regions na, di ba? Domains, holes, intercepts, asymptotes, regions, dire. So let's go to regions. Guys, where do I get the regions again? From dalawa pinagkukunan ko ng regions. All the time from, what are those two? X-intercepts and vertical asymptotes. So what are my x-intercepts and vertical asymptotes? Balikan natin. Negative 2. Ang vertical asymptote ko, 4. Yan. So yung asymptotes natin, bilugan natin na kasi later we will be using them. So with that, I'll create my table. I'll start with negative 2. It becomes 4. It becomes infinite. So look at the heading. It's the correct graph now. So I will write the factored form. So this is, of course, your y or f of x. What are the zeros? At negative 2, it's the one on top. At 4, it's the one at the bottom. Guys, can you help me think of a trial value? What's a good trial value? Negative 10. Sige. Negative 10 plus 2 is negative. Negative 10 minus 4 is also negative. So that becomes plus, minus, plus. Two negatives give you a positive, negative, positive. Okay. So let's draw the curve. All right. So let's try doing the regions first. For the regions negative 2, let's create a very, very light line. And then 4, let's create a very, very light line. In here, from negative 2, going to the left, it's positive. So dapat i-shade natin yung negative side ng graph. So we cannot have any graph there. From -2 to +4, negative daw. So we cannot have any graph here. All right. Now, from 4 onwards, positive. So bawal magka-graph at the bottom. So let's try plotting the intercepts. Let's try plotting the asymptotes. Intercepts, naka-yellow, 0, 1/2, at saka -2, 0. So, -2, 0, 0, -1/2. So those points. Okay na tayo. Are there asymptotes? Yes. X equals 4 at saka y equals 1. I'll make that red. X equals 4. We will label this. X equals 4 is my vertical asymptote and y equals 1. HA. Now, are there any crossing? There's no crossing at the HA. So what I'll do, guys, is this. I'll try to graph them now. The left side, it says there it's plus. So it will try to go near the asymptote, but it will never cross. Okay. Now here at the other side, at the middle, intercept. It will go to another intercept. And then there is an asymptote. What happens? The asymptote becomes like a what? Like a magnet, di ba? It will try to go near the asymptote, but it will never touch or cross. So it's like that. You understand what happened? Now, lastly, on top, I have two questions. Should I draw on top of this or should I draw here at the bottom? So those are my two questions. Top or bottom? On top. Yes, that's correct here. So you might ask, why is it that I have to draw on top and not at the bottom? Because if it's at the bottom, there should at least be an intercept in here if it would be coming from the bottom. Pag wala, parehong asymptote, yun itsura niya. So some of you might ask, what's the final form of the graph? If you erase the, for example, if you erase the other shadings, ang itsura ng graph ko will be ganyan lang. Siyempre, we don't need to draw all those. Kaya lang, ako kasi, it helps to visualize. So in here, again, domain. First, I'll just write dia. Let's factor out what we can factor out. So from the top, it becomes 2 x squared minus x minus 2, right? At the bottom, it becomes x minus 4 and x plus 3. Can we further factor out the one on top? Yes. That becomes 2 x minus 2 and x plus 1. At the bottom, that's x minus 4 and x plus 3. So I can see that my domain, just by looking at the factored form, x cannot be 4 or -3. Very good. So, are there any holes? Are there anything that canceled out? There's nothing. So, there's none. For the intercept, there are two types. X-intercept when y is 0, and y-intercept when x is 0. So again, let's substitute x plus 1 all over x minus 4 and x plus 3. So 0 equals 2 x minus, so x plus 1 and x minus 2. Therefore, x is either -1 or 2. So some of you might say, it's -1, 0, and 2, 0. That's correct. In here, y equals 2, -2, 1, -4, 3. What did I do? I made all the x's 0. So -2 times 2 is -4 over -4. So the answer is 1/3, right? 0, negative, positive 1/3 pala. 0, positive 1/3. Okay. So next are the asymptotes. Vertical, horizontal, and slant. For vertical asymptotes, what are the vertical asymptotes, guys? 3, -3 and 4, yes, because they are the denominators. For horizontal asymptotes, what's the horizontal asymptote? Y is 2 because they are equal in degree, just divide. Very good. Slant, there is none because meron ka ng horizontal, so you won't have any slant anymore. So, let's do the checking ng crossing. Check for crossing at the horizontal asymptote. So, 2 yung asymptote mo. I-equate mo yung 2, guys, sa equation. 2x squared minus 2x minus 4 all over x squared minus x minus 12. So, 2x squared minus 2x minus 24 is 2x squared minus 2x minus 4. Negative 24, are they equal? Hindi pwede. Right? Kasi the x's cancelled out. Therefore, no crossing. So, diar. Last na, regions. The regions come from the x-intercept and vertical asymptote. So, let's look at those x values. X-intercepts are -1 and 2. Vertical asymptotes are -3 and 4. Yan yung mga values. So, negative infinity, let's start with -3, followed by -1, followed by 2, followed by 4, followed by infinity. So guys, look, the regions in here, diba, it's defined by 4 x values. So if you have 4 x values, the regions is always +1. Kaya to 5 regions siya. So on top, as I said, the factored form is the essential one. Di ba ang factored form niya? 2 times x minus 2 and x plus 1. At the bottom, it's x minus 4 and x plus 3. You don't need to write the 2 anymore in here. Just write the x minus 2, x plus 1, x minus 4, x plus 3. And then, of course, this is your f of x, the signs. So let's look for a test value. Test value less than 3, let's just say -10. Okay. Let's write the zeros. 0 siya dito. 0, 0 on top, 0 here. So kung -10, negative, 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 negative. So I'm filling out the signs. I hope you know how to follow the table of signs. This becomes plus, minus, plus, minus, plus. Okay. Let's try drawing it. Okay. So the regions are -1. Let's draw a light line. -3, 2, and 4. Okay. From 3 onwards, shaded, Tapos negative, so shaded on top. Positive, so shaded at the bottom. Shaded on top again. And again, shaded at the bottom. Okay, let's look at the intercepts. I'll encircle the intercepts, guys, so you know what they're yellow, -1, +2, and then 1/3. There. Tapos, ang asymptotes ko, I have two vertical, one horizontal. So I can say here that y equals 2 is a horizontal asymptote. X equals 4, vertical asymptote, and x equals -3 is also a vertical asymptote. So just by looking at the shaded portions, you can definitely say that this one, kasi there's no crossing, right? Here, from this point, it goes near the asymptote. It would go on top to there, there, and then can we go to the last one? Ito, isa na lang last. I'll go ahead and draw this. So this is x minus 1 and x plus 3. This is x plus 3. So you will say that the domain x is not equal to -3 because that's in the denominator. However, guys, isn't x plus 3 repeating? They're the same. So what I can do is I can say the function can be rewritten as y equals x minus 1, but x cannot be -3. Okay. Wholes. Are there wholes? Yes. X equals -3 is a whole. So let's look at the intercepts. Again, x-intercept when y is 0, y-intercept when x is 0. So let's plug in. 0 equals x minus 1 dahil nagbago na yung equation eh. Therefore, x equals 1 or 1, 0. Y-intercept. Y equals 0 minus 1. So y is -1. Yan. Pero ang tanong, di ba may whole? So let's solve. What's the whole? Y equals x minus 1 when x is not equal to -3. So if x is -3, y is -4. Therefore, the whole happens at -3, -4. To, important to. Let's look at the asymptotes. Vertical, horizontal, slant. Vertical, di ba nawala ng denominator? Therefore, none. Dahil wala na siyang denominator, na rin siyang horizontal asymptote. Meron ba siyang slant? Wala rin. So, let's draw that. The regions come from the x-intercept and vertical asymptote. Ang x-intercept ko is 1. Wala na. Yan lang. Therefore, -infinity, 1, and infinity. What I will write here is your f of x. Pero papalitan ko yung equation, di ba? The equation is x minus 1 when x is not equal to -3. So ito, x minus 1 lang. At 1, it becomes 0. So whatever test value, it's up to you. Let's just say 0. 0 minus 1 is negative. Positive. So some of you might ask, ano itsura nito, sir? Ganito lang siya. Ito, di ba sa 1? Shaded, I should not have any graph on top. I should not have any graph at the bottom. Okay. When x is 0, 1, 0, that's an intercept. And 0, -1, that's an intercept also. Now, is there a whole -3, -4? Where's -3, -4? -1, -2, -3, 2, 3, 4. So when you graph this becomes what? Yun lang siya. It's actually a line kasi equation of the line to eh. But with a hole. So it's a linear function with restriction. Okay. So let's try this. If I want you guys to sketch this polynomial function, what if it's a polynomial function? So sabihin mo, domain, alam mo pag polynomial, alam mo na agad na all real. An element of all real. By the way, if I ask you pala, you know how to solve for the domain. Now, I'll ask you, what is the range? The range in here is all real numbers except, hindi siya nag-cross, except y equals the horizontal asymptote in here. Ito, so that means ang graph mo from 2 upwards, bawal yung 2. And then in here, ito kasi rough lang. So most likely, we don't really ask for the range. Pero in here, yeah, domain, holes, none, intercepts, x-intercept, and y-intercept. This happens when x is 0. This happens when y is 0. Okay, guys. So when y is 0, x minus 2, x minus 3, x plus 1, x minus 5. Ang dami nating x-intercept. 2, 3, -1, and 5. In here, y-intercept when x is 0. So y is -2, -3, 1, -5. 2 times 5, 10 times 3 is 30. So -30 pala. So let's rewrite this. 2, 0, 3, 0, -1, 0, 5, 0. This one is 0, -30. Some of you will ask asymptotes, vertical, horizontal, and slant. There's none. Bakit? Because polynomial. Therefore, tapos na. Ano na? Regions na lang. Regions. Negative infinity. Ito na yung regions ko eh. -1, 2, 3, 5, up to infinity. So I'll write here the x minus 2, x minus 3, x plus 1, and x minus 5. So let's write the zeros. Zeros would be here, 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 and here. So let's have a test value. Let's just say -10. That becomes negative on the first line. So let's fix this. This becomes plus all throughout, minus, 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 plus. So 4 negatives is positive, negative, positive, negative, positive. So when we graph that, guys, -1, 2, 3, 4, 5. Let's go for the regions. Negative one here. Okay. So what are the intercepts, guys? The intercepts are these and this. So this one is -1 to -1 to, so I'll make it yellow. So -1, +2, and then +3, and then +5. Okay. And then 0, -30. Let's just say this is -30, guys. So let's do the shading. From -1 onwards, it's positive, so I can't have any graph at the bottom. Between -1 and +2, it's negative, so I can't have any graphs on top. And then in here, it's positive again, so no graphs at the bottom, no graphs on top, and lastly, no graphs at the bottom. So how do you draw this? Something like this. Kasi sila, ano, di ba, look at this. What's the degree? When you look at the degree, it's degree 4. Am I correct? Kasi x, 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 right? So look at the number of changes. Follow my pointer. Look at the number of changes. Negative slope, 1. Positive slope, number 2. Negative, positive. So there are 4 changes. 1, 2, 3, 4. What's the degree? Degree is 4 in here. All right?